Okay, this is the second part of the derivatives of trig functions. I forgot to do this one. So it says, this is problem 44. The depth y in feet of water in the Boston Harbor is given in terms of t, the number of hours since midnight, right? So let's find dy dt. dy dt. First of all, derivative of 5 is 0, right? So we'll come over here and we'll say the derivative of cosine is sine. So it should be 4.9 times the sine. Oops, the derivative of cosine is negative sine, isn't it? Pi over 6t. And then the derivative of the inside of this is pi over 6, isn't it? So this is negative 4.9 pi over 6 sine of pi over 6t. What does dy dt represent in terms of water level? It should be the instantaneous rate of change of the water level. Right? These derivatives are always the instantaneous rate of change, right? And we want to say hours since midnight. We're going to keep that in mind on the next slide. All right, so here's what this function looks like. It says, for the time frame t is greater than or equal to 0 and less than or equal to 24, when is dy dt 0? So dy dt is the instantaneous rate of change, which is also the slope, right? So the slope is 0 at the extrema, as they like to tell them, the max or min. So it should be 0 at t equals 0, 6, 12, 18, and 24. See? And then it says, explain what it means in terms of water level for dy dt to be 0. Well, I think it means at midnight, 6 a.m., 12 noon, 6 p.m., and 12 midnight, exactly at those points, the instantaneous rate of change of the water level is 0. Exactly at those points, instantaneously, the water level is not changing. Okay? And that's usually what's happening. It's changing up until that point. It stops for that moment, and then it starts changing in the other direction. So it should mean at those points, the water level is not changing. And that would be at those points instantaneously, right? Because that's what our slope is measuring, isn't it? All right, this is done now. So this is the completion of the derivatives of the trig functions.